Okay, so for this video, we're multiplying numbers written in scientific notation. The one thing that I do with these, kind of weird, is I know that the times for the scientific notation thing, if I really want to think about it, I could change this to be just the parentheses. It sometimes makes life a little easier. So this is really the same thing as 1.2 times 10 to the 6th times 3 times 10 to the 8th. And then I know I can multiply things in whichever order I want. So I'm going to do 1.2 times 3, and then 10 to the 6th times 10 to the 8th. I know when I have things with the same bases, I can add their exponents. So this is going to be 10 to the 14th. And 1.2 times 3 is really just 1 times 3 plus 0.2 times 3, which is, or 12 times 3 with a decimal in between. So this is 36, or 3.6, sorry. And then I'm going to just rechange back instead of my parentheses. I'm going to go back to the x for the times. So this is going to be 3.6 times 10 to the 14th. I know there's more elegant ways of doing this, but that is really how my brain works. So 3.6, and I have too many decimals, and then times 10 to the 14. Okay, and just make sure that you're still in scientific notation, where do you have one number, a decimal, and then the times 10 to, or the rest of the number, and then the times 10 to the whatever. And we are going to get another problem. This is going to give us 3 of them we're going to have to do. All right, so this time I have 2 times 10 to the 6th times 3 times 10 to the 7th. So this is the same thing as doing 2 times 3, and then times 10 to the 6th times 10 to the 7th. Those 10s are going to be 10 to the 6 plus 7 is 13. And then 2 times 3 is 6. And remember, there is a decimal after that. So I only have one digit to the left of the decimal. So this is just going to be 6. And you could do 6.0, but since we're talking the scientific notation we have, we're not going to add any extra zeros because they didn't give them to us to begin with. All right, and one more problem, then I can move to the next video. All right, clear pictures. Next problem, nice short video. Okay, so we have 8 times 10 to the 7th times 7 times 8, 10 to the 8th. Okay, so 10 to the 7th. Actually, I didn't mean to. Okay, so 8 times 7, so 8 times 7. And then I have times 10 to the 7th. And 10 to the 8th. Those bases are the same, so it's going to be 10 to the 15th. And 8 times 7 is 56. This is too big to be in scientific notation, so I have to think to myself, if I want it in scientific notation, is my number getting bigger or smaller? And I need it to be 5.6. The number got smaller, so the exponent has to get bigger. So our real number is going to be bigger, meaning our exponent is going to get bigger, and it's going to become 10 to the 16th because I just added that one decimal point to make sure that I stay in scientific notation. All right, so 5.6 in standard ALEKS fashion, they gave us the harder one for the last problem. So just be careful that you end up with your answer still in scientific notation. If your number gets smaller, that means your exponent has to be bigger. So I'm thinking of what my real number was when I'm thinking about that. So they take a little bit to get used to. If you're in a medical field, you're kind of used to them a little bit better. So hopefully it'll work, and we'll see you in the next video.